Hello everyone to this lecture about discrete and continuous probability models. In the case of discrete probability models, the sample space is a countable set. So for example, if we have an example of flipping a coin, the result will be, or the outcomes will be just heads or tails. This sample space is a countable sample space because it has just two elements, so we can get another outcome rather than heads or tails. So in this case, the sample space is finite and countable sample space. However, in the continuous case, the sample space is an uncountable set. For example, when you wait for a bus or a train that you know that it will come between 11 and 11 o'clock and 11:30, for example, you probably will wait between 0 to 3 minutes. So this is an interval, is an uncountable interval. You can't specify a point that the train or the bus can come at this point, for example, specific points, because this is uncountable set or uncountable interval. So this is the difference between the discrete and continuous probability models. Now let's talk about random variable. The random variable is something that you will hear about lots because it is very useful in probability, and it is very important also. Let's define what is a random variable. A random variable is a function from the sample space to the real numbers. So for probability, for the mathematics, and also for the computers, it is better to deal with numbers. For example, in the case of flipping a coin, we have heads and tails, but it is better to define them as numbers. For example, to define them as 0 and 1, 0 for heads and 1 for tails, or the opposite, so it doesn't matter. And it is important to note that you can define many random variables from the same sample space. So for example, if we flip a coin two times, the outcomes we will get can be heads in the first flipping and heads also in the second, or we can get heads and tail, or the opposite, tail and heads, or we can get tails at in the two experience. But we might be interested just about the number of times that heads are appearing. For example, we can consider these events as the same, and we can represent them by a random variable like 1, for example, and we represent the case where there is no heads by 0, for example. And in this case, the new random variables will be 0 for the case where we have a head, and 0 for the case where we don't have a head. Or we can also represent it can be also the opposite. For example, we might be interested just about the cases where we have the tail, and we consider these three events as one event, and the other is its complement in the sample space, and so on.